going to continue with these integration techniques. Potentially. Come on, buddy. Here we go. So, sometimes we are going to have to tweak our function in order to fit a rule. We have new seats today, Sean, so you sit over there. And we're just getting started. Okay, so look at this. The integral of 1 over 1 plus e to the x dx. Right now, can we do anything to this? It's possible.
No. We have no rules to integrate the function as.
We have no rules to integrate the function as is. What would be helpful? Like, we cannot separate a denominator.
Partial fraction decomposition.
We can factor this?
Maybe. No.
Okay, so partial fraction decomposition would only work if we could factor that out. Okay, now if we had e to the x over 1 plus e to the x, would that be helpful?
Yes. Yeah.
Because we could do u du substitution, right?
Yep.
Well, I can't just like magically put an e to the x in the numerator, right?
Well, you could multiply by e to the x over e to the x.
Okay, and so if we had this,
And that's one way to solve 1 over e to the x.
and that's going to be kind of messy too, right?
Let's pick.
But if we let this be u, then du is e to the x, and we have another extra e to the x floating around. Okay. This gives us too many e to the x's. Okay. So instead, what we can do is, instead of multiplying by the well-chosen 1, we can add a well-chosen 0. Okay? Is adding 0 okay? So what if I add and subtract e to the x? Is that legal, first of all? Okay. Now, how can that be helpful? What we now can do is now we can split this fraction apart to 1 plus e to the x over 1 plus e to the x minus e to the x over 1 plus e to the x.
That's 1 minus e to the x over
Okay, yes. So we have the integral of 1 minus e to the x over.
and then we use substitution.
Okay. Now this looks nice for u du substitution. What would we let u be?
1 plus e to the x.
Which means du is. So we have the integral of 1 minus 1 over u du. Well, no. How about we do this? We are going to have to take it apart. I'm sorry. 1 dx minus 1 over u du. Okay? So the integral of 1, or the antiderivative, excuse me, x minus antiderivative of 1 over u. So the natural log of 1 plus e to the x. Is it okay if I don't put absolute value?
Yes.
E to the x is always positive. So 1 plus e to the x will always be positive. Okay? So we've always had the tools to do this integral technique. I mean, this is just some algebra skills, but we've just never done them before. So let's talk about some other algebra techniques that we could do to tweak our function to fit a rule. Okay. We could expand the numerator, separate fractions, complete the square. Okay, that could be something that is helpful to fit one of the inverse trig rules. Okay, if we can complete the square so we can have 1 plus something squared, or the square root of 1 minus something squared. Okay. Divide an improper fraction. We saw that on Tuesday. We just added and subtracted terms in our numerator in this last example. Trig identities can help us rewrite something. And Pythagorean conjugates. What do I mean by a Pythagorean conjugate? What do I mean by Pythagorean conjugate?
Is this like 1 minus sine cosine?
Right. Like, if we had a 1 minus sine of x, we can multiply by 1 plus sine of x, numerator and denominator, and then we could have trig identities help us out. Okay. So we're going to do a few examples where I'm going to give you the problem. I want you to think about it, and then you're going to text me an idea of how we should go about performing an integration. Okay, keeping these strategies in mind. Okay, that way we're not all like shouting all at once. Okay. So I'll let you finish writing this down. It will not tell, no, I will not know who is texting what. Okay, so what's going to happen is you're going to text an idea and it's just going to pop up here. I'm not going to know who it's from. I can go look it up later, but nobody else is going to know who's texting what, okay, unless you shout it out. What is the meaning purpose of what I want to do? So, write this example down. And then what you're going to do is you're going to text Harry Holman 260 to this number to join in the conversation. So once you've done that, then you're going to tell me what strategy you want me to use or you think would be best. And once you text something, your idea is going to pop up here. Okay, so what strategy would be best to integrate this example? When you join, you get a response saying, yes, you joined, but then you will not get a response after that.
So once we're in, you know, let's text ours.
Once you're in, text me how you think we should tweak this integral. It's not open? Is anybody else getting that?
I'm getting it.
Is it working?
No. Oh, I wouldn't know, actually, it's frozen, so.
I'm saying, but like,
I'm not gonna.
I'm getting your presenter, Gray Holman, with no typical tribal women acting.
I was told I was gonna let it get shut down because it got too many texts at the same time.
it wouldn't do that. Try to send the text again, Graham. Yay, okay, so I wasn't like logged in for some reason. Okay. Okay, any other ideas? I like the Carrie Holland 260. I think that's an excellent idea.
Sorry. Like I said, it was joined you before I even sent the text. No, I think it recognized that I've already sent them off.
Okay. Well, we have two different strategies that are thrown up here.
Oh,
What's improper fraction one? Improper fraction is.
When the numerator is bigger than the denominator. So I want to know the adding one and subtracting one.
Yeah,
How would that help?
because then you can factor you can split up, then you get x squared minus one over x plus one plus one over x plus one, and one over x plus one just becomes like the natural log of the absolute value of x plus one. And the other one, you'll just end up with like x minus one, so then you get like 1/2 x squared minus x.
Okay, so he's saying plus 1 minus 1.
Yep.
Okay, so here's the minus 1, and this would reduce to what?
X minus one.
X minus x minus 1,
Yep.
right?
Yeah.
And this would be just 1 over x plus 1 dx. Right?
And you get 1/2 x squared minus x plus the natural log of the absolute value of x plus one plus.
That worked out for us, didn't it? Okay. Now, someone also suggested, what if we divide, what was it, improper fraction, right? Hold on. Divide improper fractions. Okay? Is this an improper fraction? Yes. So what I'm going to do, solve it. Okay? How do we divide improper fractions?
I'm so confused as to what improper fraction is.
Give
Is that
me
like
it.
7/4? Is that?
7/4 is an
But-
improper fraction.
But
because
what if
the-
it's a value like 0.2? Yeah, something less than 1.
0.2 would be like 2/10.
Yeah.
That's not improper because it's
But plugging that in for x, then you get like 0.4 on the top and 1.2 on the bottom. That's technically an improper fraction.
okay. So let's look at this just with x's. The degree of the numerator is larger than the degree of the denominator,
Okay.
which means division is possible. okay? So let's divide these. X times what is x squared? Divisor times x goes here, and what do we do with this? So we are left with negative x plus 0. X times what is negative x? So we take subtract. So we have a remainder of
1 over x plus 1.
okay. So this integral, when we do the division, is x minus 1 plus 1 over x plus 1. Hey, that looks familiar, right? One problem, two different ways to do it. Okay? However you see it, as long as it's mathematically correct, great. I'm really glad we did that. That was nice. Got another one. Write it down, and then I'm going to give you an opportunity to text in your answer, or text in your idea, all right? Ready? I see a theme. Do you think we should try Pythagorean conjugates?
No.
Wait, what? Did you text me? So let's go back to here. What would we do? So then our integral would become cosine of theta plus 1 over cosine squared theta minus 1. That's all fine and dandy.
Negative.
Okay.
Moving the 1 over and the sign over.
So we have cosine theta plus 1 over negative sine squared theta.
Separate the, separate factors.
Okay, we can't do u substitution yet because, first of all, our u is going to have to be sine, right? Well, we have cosine plus 1. So we're going to need to separate this out to negative cosine over sine squared minus,
Wait, aren't you missing like a d theta?
and what is 1 over sine squared? So I'm just gonna subtract cosecant squared, is that okay? Alright. So now let's work on this first integral. We can let u be what? Sine theta. So du is cosine theta d theta. So that integral becomes negative u to the negative second du. And then we have minus cosecant squared theta d theta. So when we integrate this becomes u to the, so just goes to positive, right?
Plus
Minus a negative cotangent theta, right? So we have
plus
1 over sine theta plus cotangent theta plus c, which I would probably prefer you to write cosecant theta plus cotangent theta plus c. Yep.
Just use cotangent over sine squared, or cosine over sine squared is equal to cosecant cotangent.
Yep. Everyone see that?
Yep.
Cosine over sine is cotangent with an extra sign in the denominator would be cotangent cosecant. Makes sense. Did it work this way? Yep. Okay. It's the beauty, right? You do things in multiple ways. All right. Another example. Write it down. And then text me an idea. Oh, okay. I'm viewing this weird. I was trying different ways to like view answers. Yeah, I did a Wordle and it's not working. Oh. Well, this stinks. Sorry, people back home.
that makes more sense now.
Other ideas? Only 2 people brave enough? Isn't quite working out the way I wanted it to. Z square. Okay. How do we do that? First of all, what does the coefficient need to be, the leading coefficient, to complete the square? It needs to be a positive 1. So we need to factor out this negative. We're going to add a mystery number. And then we're also going to have to subtract that mystery number. Now,
I was thinking add 3 to the top. And no. I was thinking multiply by a specific one. So you're multiplying by that 9
negative on this, okay.
9. Oh, yeah. Really good.
Let's go through this strategy first, and then we'll go back to what you're trying to tell me. 'Cause I'm not following. What goes here?
9.
But what are we really adding?
Negative.
Which means we need to subtract -9. So what we really have is 3 over the square root of 9 minus x minus 3, the quantity squared. Does everyone see how I got there? All I did is I took this 9 and put it first, minus what we did to complete the square.
Why are you adding
Because we added, okay, so we added a -9, which means we need to subtract a -9.
the negative?
Yep.
Okay, so why is this helpful? Now what does it look like?
Oh, one of the
Aha,
the trig ones.
which one?
So,
First one.
Okay, so we would have to let u be what? X minus 3, which means du is dx. So if we look at it as, I'm going to move the 3 out front, 1 over the square root of 3 squared minus u squared, right? Now that is exactly the fit to the rule, right? We have this 3 times, what is our rule? Arc sine of so we have 3 arc sine of x minus 3 over 3 plus c. You will have to complete the square. Know how to do it. Okay. All right. I think we have one more example where I'm not going to make you text me anything. Okay. Now, we've been doing lots of different funky ways to compute these integrals, so I don't want us to lose sight of things we know from before. Okay. First of all, what does average value mean?
1 over b minus a integral of f of x dx from a to b. Yeah.
Oh, and why do I have x's and t's all together? I don't know. Just assume those t's are x's, please. I'll fix that. Assume the t's are x's. I'm sorry, Kathy. And Anna and Marianne. Okay. So what we have is 1/2 integral 1 to 3 e to the 1 over x squared dx. What will we do?
Isn't the derivative of 1 over x something like 1 over x squared? I believe it's -1.
It is. So how is that helpful?
We have 1 over x squared.
We have a 1 over x. Du is -1 over x squared dx. And we have that right there. Except we would need a negative. Now, do you guys change your limits of integration or just do the integration and then go back to the x's?
I
go back to X's.
Do and don't, really depends on how I'm feeling.
Depends on how you're feeling. So let's just do this. -1/2 integral e to the u du would be -1/2. Okay, so I'm just going to write e to the 1 over x, and we're going to evaluate it from 1 to 3. So we have -1/2 times e to the 1/3 minus e to the 1st. On a non-calculator portion of a quiz or test, that is how I would want to see the answer. I'm confident that you can do that in your calculator if I would ask you, but I'm not going to worry about it. So, here's your homework. I also have a Throwback Thursday for you. The Throwback Thursday, I'm hoping, will not take you very much time because it's some basic stuff from Calc 1. We have 11 minutes left in class. Can you get started on whatever you like? Well, this is like 7, 8, 9, 10, 11, 12, like 13 problems. Because it's 27 to 41 odd, and that's only like 7 or 8 problems, isn't it? 8, 9, 10, 11, 12, 13, 14. Some of them will be quick.
It's the ones that aren't quick that worry me.